Greetings and welcome to our guided notes on multiplication as area. I would hope that at the end of this we will all be able to multiply fractions using an area model and explain what happens. We're going to be filling in the blanks as we go, so get your pencil ready, get your paper ready, and here we go. Since the area of a rectangle is the product, meaning the result of a multiplication of its length and width, right? We just multiply the length and the width and we get the product, which is the area. You can represent the product of two numbers by determining the area of a rectangle with those numbers as length and width. Let's look at an example. So, to figure out the area of a 2/3 by 3/4 rectangle, you could start with a 1 by 1 square, then divide it horizontally into thirds, and then divide vertically into fourths, like they've done right here. You then figure out what portion of that 1 by 1 square is covered by a 2/3 by 3/4 rectangle, and you can see the length here is 3/4 of whatever unit you're doing. And this area, or this length here, is 2/3. You can see that 6/12 of the rectangle with an area of 1 square unit is in the smaller shaded rectangle right here. There's 1, 2, 3, 4, 5, 6 out of a total 12 of those squares, so 6/12. And you can see that if you were to take these two squares and move them over here and here, you could tell that exactly half of this unit would be shaded. Moving on. Using an area model works even if the fractions being multiplied are greater than 1. For example, to multiply 5/3 by 3/2, you could start with a 1 by 1 square unit, then copy it to the right and down. So here they've now have 2 units, and when you get down to here, they've got 4 units total. So now, to represent the product of 5/3 and 3/2, you could shade an area that is 5 rows each. That is 5 rows, each of length 1/3. So here we've got 1/3, 1/3, 1/3, and by 3 columns, each of the width of a half. So here's a half, here's a half, here's a half, right? And we know this because this is actually the unit, and we've split the unit into halves. So here's 1/2 of that one unit, and this is 1/3 of this unit. Okay, but we know we don't have just 2 halves, we have 3 halves, bigger than 1. It's an improper fraction. And here we know we don't have just 3/3, we've got 5/3. It's bigger than 1 in an improper fraction. You can see that the larger shaded rectangle is 15, right? Because it's 3 by 5 units. So it's 15 by 15/6, because now we're talking sixths, because the unit is here, and how many equal pieces fit in? There are 6. So it's 15/6 of the square with an area of 1 square unit. So the product of 5/3 and 3/2 is 15/16, or 5/3 when you simplify it. And actually, I think that they've made a mistake. I don't think it's 5/3, I think it's 5/2, and I'll show you why. I think that everybody should do this with me. Let's cross this out. It's 5/2. It's not 5/3. Here's why. If you look, here's 1/2, here's 2/2, here's 3/2, and then you would have to take, 3/6. Here's another 3/6 for 4/2, and another 3/6 for 5/2. It's 5/2, not 5/3. That was a mistake. Let's move on though. When you multiply fractions using the conventional strategy, you multiply the numerators to get the numerator of the product, and multiply the denominators to get the denominator of a product. That is, A times C goes on top, and B times D goes on the bottom. For example, when you have 2/3 and 3/4, you can also write it as 2 times 3 over 3 times 4. So in this picture over here of a rectangle with a width 2/3 and length 3/4, as you can see, 3/4, 2/3, you can see that there are 3 by 4 equal pieces, right? 3 by 4 equal pieces. That means the denominator has to be 12 because it's out of 12. Since you divided one dimension into thirds and the other into fourths. That makes the denominator representing the area 3 by 4 or 12. You can also see that 2 by 3 pieces, 2 times 3 pieces, are shaded since you used only 2 of the 3 rows and 3 of the 4 columns, right? We used 2 out of 3 and 3 out of 4, and that's the area we shaded. So that makes the numerator 6, 2 times 3. So that means that 2/3 times 3/4 is just 2 times 3 over 3 times 4, which is 6/12, which is also, if you move this down and this one down, then you will have exactly half, which is 6/12. If both fractions are less than 1, the area of the rectangle will be less than 1 square unit, so their product will be less than 1. You can see that based on this picture here. This side length is less than 1, and this top width is less than 1, and the area is also less than 1. But if both fractions are greater than 1, the area of the rectangle will be greater than 1 square unit. So their product will be greater than 1. If one fraction is greater than 1, and one fraction is less than 1, let's write that in, and one is less than 1, their product could be greater than 1, less than 1, or even equal to 1. And let's look at each of those examples. Okay, the area of a rectangle that is 2 2/3 by 1/2 is greater than 1 square unit. So let's write more than 1 square unit. So the product of 2 2/3 and 1/2 is greater than 1. You can see that based on this picture. If you just took these 3 and moved them on in here, that means we would have 1 and we would still have 2/6 left over. Next, the area of a rectangle that is 1 1/3 by 1/3 is, what is it? It's less than 1 square unit. So the product of 1 1/3 and 1/3 is less than 1. And you can see that if you just move that inside here, you would have 4 out of 9 equally sized pieces. Then the area of a rectangle that is 1 1/2 by 2/3 turns out to be exactly 1 square unit. So the product of 1 1/2 and 2/3 is 1. You can cut the shaded part to the right of the unit square horizontally in half to fit the missing pieces in the bottom of the left unit square, just like we've been doing on all the other ones. We move these over here in our minds and we can see, oh yeah, that does equal 1. Then you can multiply mixed numbers. For example, 2 1/2 times 1 1/2 as improper fractions and divide the product of the numerators by the product of the denominators. So first trick is actually getting these these mixed numbers into improper fractions. The way that we do that is, I'm going to show you how I think of it first, and then I'll show you a trick to do it really quickly. So when I look at 2 1/2, 2 1/2 really equals 1 plus 1 plus 1/2. You with me? And a 1 can be written like this, 2 over 2. So if I have a 1 plus a 1 plus another half, now I'm just adding halves, right? So if I have here 2 halves plus another 2 halves, well, what I have 4 halves now, and now I have 5 halves. So eventually that equals 5 halves. So all of this is just to say that that equals that, right? It's a long way to get there. The easier way to think of it, or the easier way to get there quickly, I should say. I like to think of it that way. But you can go take this whole number, multiply it by the denominator, and then add it to the numerator. So I go 2 times 2 plus 1 is 5. Here I would go 1 times 2 plus 1 is 3. So now we have our improper fractions, 5 halves times 3 halves. And now all we have to do is we remember we can just multiply our numerators and our denominators. 5 times 3 is 15, 2 times 2 is 4, and then we simplify. How many times does 4 fit into 15? And we can do this. 4 fits into 15 like this. 4 goes into 15 3 times. 3 times 4 is 12. What do we have as a remainder? We've got 3. We've got a remainder of 3. So we have 3 wholes right here, and we have 3/4 left over. Okay, and if we look at the picture, we can see we've got 1 whole, 2 wholes, and if we move these pieces over here, we'll have 3 wholes. And how many pieces left over? We already used these 2, so we've got 1, 2, 3/4 left over. Finally, let's have a look at our key terms for today. Our denominator is the number below the bar in a fraction, which tells the number of equal parts in the whole. For example, the denominator of 3/4 is 4, which means that the whole is divided into 4 equal parts. A fraction, a number that represents part of a whole. For example, 2/3 is written like this, 2/3. An improper fraction, a fraction with a numerator equal to or greater than the denominator, for example, 6/6 or 8/5. A mixed number is a number that consists of a whole number and a proper fraction. For example, 5.5. A numerator, the number above the bar in a fraction, which tells the number of equal parts that the fraction describes. For example, the numerator of 3/4 is 3, which means that 3 out of 4 equal parts are being described. And a product, the result of multiplication. So write that last one in. For example, in 3 times 4 equals 12, 12 is the product. All right, thanks for watching. We'll talk to you next time.